All right, thanks for watching. And today I want to show you how to draw the graphs of certain trig functions, starting with sine of x. So let's try to graph y equals sine of x. So again, in the xy plane. Now, of course, you could do it by plotting certain values of sine, but I think it's much more easier to do if you just draw the unit circle. Because I would like to remind you, if you have a circle of radius 1 and an angle of theta, then the x-coordinate is given by cosine of theta, and the y-coordinate is given by sine of theta. And my suggestion is, think in this case like a Ferris wheel. So suppose you are on a Ferris wheel here, then sine of theta just gives you the height of the Ferris wheel. And so the graph answers the question, how high are you at what point? So let's start at an angle of 0. Let me use slightly different colors here maybe. So at an angle of 0, well, you're just starting. So you're at the point 1, 0, and in particular, your height is 0. So in particular, sine of x starts at 0. And then see what's going on. Suddenly, your height increases by a lot. Because you see here, we barely moved, and we're already at this point. So what happens is sine of x goes up by a lot. But then roughly around here, it goes down by a very little, because you see, we changed the angle by so much, but we just went up by a tiny little bit. So it goes up very fast and it decreases. I mean, it increases a little bit more slowly up until we're at this point, which is 0, 1, which, if you notice, corresponds to an angle of pi over 2. So you see at pi over 2, you're at an angle, you're at the height of 1. So you see sine of x, again, it goes up very fast, then a little bit slowly up to 1. But then the question is, what happens after pi over 2? Well, kind of the reverse phenomenon. You go down very slowly, so think almost like a roller coaster, a little bit, and then whoosh, you go down very fast. Kind of like here. Up until you reach this point, -1, 0, where your height is 0 again. And the question is, what is the angle? Well, it's 180 degrees or pi radians. So just to recap, sine starts at 0, goes up very fast, then goes up slowly, and then goes down slowly, and suddenly very, very fast. And the question is, what happens here? Well, here it continues its momentum. It goes down, your height goes on very fast, and then again, very slowly. So kind of like here, whoosh. Up till you reach this point, which is 0, -1, which tells you your height is -1. And then what is the angle here? Well, it's 3 pi over 2. So it's this 3/4 of a circle. And then again, same thing here. You see, you can almost connect the lines. So then you increase very slowly, and suddenly you increase very fast. Kind of like this, whoosh. All right, and then what point are you back at? You're back at 0 radians, but it's really the same thing as 2 pi radians. Good. So again, you start at 0, increase fast, slowly, slowly, fast, fast, slowly, slowly, fast. And then what happens at this point? Well, you've gone full circle, so you start again, which means to draw this graph, it's called periodic. It means you just start again the way you started. So again, you go up very fast, slow, fast, slow, fast, slow. And then you repeat this infinitely many times. And same theory, by the way, in reverse. So here you go down slow, fast, up, up, down. And so this is the graph of sine of x. Let's see if maybe I can zoom out so you can see something better. Yes. So you see it just like a roller coaster, it just wiggles around. And it turns out for cosine, it's almost the same thing. So, all right, and now that we know how to draw the graph of sine, let's try to draw the graph of cosine. And it's actually the same idea like the Ferris wheel, except a little bit more complicated. So again, suppose you have the unit circle. And I would like to remind you that if you have the unit circle, again, of radius 1, and you have an angle theta, then the x-coordinate is given by cosine theta, and the y-coordinate is, as usual, given by sine of theta. Now, before we looked at the x-coordinate, so before we looked at the height, which was the y-coordinate, but this time, we need to look at the x-coordinate, which is cosine of theta. So it's like the Ferris wheel, except with the x-coordinate. So let's start at 0. At 0, we're at the point 1, 0. So the x-coordinate, again, not the height, but kind of, the how far right you are, it's 1. So cosine starts at 1. And then notice, if you increase the angle, then, well, the x-coordinate doesn't decrease that much. Because if you're going all the way up to here, the x-coordinate just decreases by that little. So what this says is, this cosine, it just decreases a little bit. But then, if you here, for instance, and you go up, the angle doesn't increase much, but the x-coordinate decreases by a lot. So you go up, you go down a little bit, and suddenly you go down very fast. Up until you reach this point, which is at an angle of pi over 2. And what is that point? It's the point 0, 1, where the x-coordinate is 0. And then kind of the same phenomenon happens where suddenly your x-coordinate decreases by a lot. So it still goes down at this momentum. And then it just decreases by a little bit, kind of going like a huge angle from here to here. You just have this little decrease. So then it just goes up to the angle pi, which is the point -1, 0. So cosine of pi, it's -1. And then, well, you just repeat that. So going from pi to 3 pi over 2, what happens is suddenly you increase by a little bit, and then you gain back momentum. You increase by a lot. And that's at 3 pi over 2, which is, again, the point, in this case, 0, -1. And again, the x-coordinate is 0. And lastly, to go from 3 pi over 2 to 2 pi, kind of, again, the same phenomenon happens. So suddenly your x-coordinate increases by a lot, and it increases by just a little bit. Kind of sort of like this. And then, well, once we've done one full revolution, we just need to repeat that. So what the graph of cosine looks like is, again, some sort of roller coaster. Kind of like that. Okay. You also do it for negative angles. So in fact, it is the same as the graph of sine, except shifted. And in fact, this is true. Cosine is just sine, but shifted. So it's not a surprise that the graphs look the same. All right, and then what other things you need to know is, just like for functions that you can shift them, dilate them and everything, you need to know how to do the same thing for sine and cosine. So let's try to draw the graph of 2 sine of 3x. So let me remind you what sine looks like. So it goes up and then down and then up and then down. Kind of like that. And then for this, my suggestion is look at the zeros. That's kind of very helpful for me. So sine of x, remember the zeros at pi, at 2 pi, 3 pi, etc., etc. Or as I like to say, at Peyam, so multiples of pi. And in particular, let's see what happens with this graph. So if you do f of 3x, remember you compress the graph by a factor of 3. So if you do sine of 3x, what will happen? The sine of x becomes compressed by a factor of 3. And in my opinion, as I said, the way to draw it is to look at the zeros, which here are pi, 2 pi, 3 pi. So if you compress it by a factor of 3, the new zero becomes 3x equals pi, which is pi over 3. So before the zeros were multiple of pi, now the new zeros are multiples of pi over 3. So pi over 3, 2 pi over 3, etc., etc. And that can help you draw the graph. In fact, I'll show you in a second how. So what does this function do, the original one? It goes up to 1 and then goes down up to pi. Well, here's the same thing, except it goes up until 1 and then down unto pi over 3. Because you see, you compress it by a factor of 3. And then you just repeat. So it goes down and then goes up at 2 pi over 3, and then it goes down, and then again goes up. So you see how it compresses it? Before, every wave was at pi. Now every wave is like at pi over 3. Okay, so kind of like this, and then just do it again. Ooh. All right. So it's kind of hard to see here, but as I said before, it was just a usual sine function. Think of it as a string, but now you're just compressing it and make it go, if you want, 3 times as fast. And last but not least, what happens to this factor of 2, that is much easier. It makes it go 2 times as high. So you're kind of amplifying it by a factor of 2. And again, let me show this a little bit. So before, you have this sine, or like the sine of 3x that goes up until 1, but now you just make it go up until 2. So you're literally amplifying this effect. So you're literally making it twice as big. All right, also here, make it twice as big. I know, my apologies for my awful art skills. But let me again show you what it looks like in the end. So again, what it looks like, it's like sine, except 3 times as fast and 2 times as high. So kind of looks like this. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Kind of like that. All right, anyway, I hope I was able to convince you again. It's compressed g times, and it goes up by a factor of 2. That was one thing. Last but not least, there's some jargon with sines and cosines. So, and again, let me give an example of this. Let's do, okay, let's see. How about y equals 3 times sine of, let's see, 2x plus 5. Something like that. Then there are a couple of things. One, it's called the amplitude. The amplitude is just the absolute value of this outside number. So with the absolute value of 3 here, which is 3. And then there's something called the period. So in other words, how many times does it repeat itself? And there is a formula. I wouldn't even memorize it. It's much easier to do it as follows. So once I can get this to work. So it's 3 times sine of 2 times x plus 5 halves. So you see, usually the period would be 2 pi. But because we're multiplying it by 2, it's kind of like the last example where the zeros become much smaller. So here the period is actually 2 pi divided by whatever number you have here. So in this case, 2 pi divided by 2, which is pi. So remember again, for the sine of 3x, right? I did the zeros, which were pi, but in general, the period is 2 pi, and you divide by 3 because it's 3 times as fast. Here, you take the 2 pi and you divide it by whatever number you have here. So that's one thing. And then there's called the phase shift. Again, don't memorize the formula. Here is much easier. Once you factor out this number, this coefficient of x, then the phase shift is almost here. It's not quite 5 halves, but you see, if you do x plus 5 halves, you actually have to shift it to the left by 5 halves because we give you more time. And because you shift it to the left, it's like doing minus 5 halves. It's like shifting it to the right by minus 5 halves. So the phase shift is actually minus 5 halves. And I believe that's all you need to know about it. And so this ends my little primer on graphs of trigonometric functions. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.